can register from there. So I'd like to introduce our next two speakers. Abby Tobin is with the Washington State Department of Fish and Wildlife, and Ann Froschauer is with the U.S. Fish and Wildlife Service, and they'll be co-presenting about white nose syndrome, a deadly disease in bats. So thanks, Abby.
Hi, everyone. Excuse me. Does that sound all right? Great. Yeah, so I'm Abby Tobin. I am the White Nose Syndrome Coordinator for Washington Department of Fish and Wildlife. Ann Froschauer, she unfortunately was not able to make it today due to a work emergency, but she is our Regional White Nose Syndrome Coordinator for U.S. Fish and Wildlife Service, so I work really closely with her in our response to white nose syndrome. But before we talk about white nose, let's just talk briefly about bats. Why are bats important? As many of you probably know, they provide essential ecosystem services. They are pest control. They eat moths, beetles that might damage agriculture. They feed on potential insect vectors like mosquitoes. They also are pollinators and can disperse seeds. Not here in Washington, but down in the Southwest, that they have a lot of species that are pollinators and feed on fruits. Unfortunately, there are lots of threats facing bat populations currently: degraded or loss of roosting and foraging habitat, disturbances at roost either in the summer or winter primarily. Also, wind energy is a new threat that can impact some species pretty severely. And then emerging infectious diseases such as white nose syndrome. And so let's just start talking about that. So white nose syndrome. It was first discovered in North America in 2006, 2007, the winter in upstate New York. There's a cave there that is a show cave, and so it's visited pretty regularly by people, and they noticed this odd white growth on the noses of the bats that were in there. And so since then, there was a lot of work done to figure out what this disease is. And we've kind of come a long way since 2006. But currently, white nose is found in 33 states and 7 provinces. There are additional 3 states where the causative agent has been detected, but not the disease itself. And I'll show a spread map in just a second. So white nose is a fungal disease. It's caused by a fungus called Pseudogymnoascus destructans. I'll be referring to it as PD, much more easier to say. But this is a cold-loving fungus. It needs very specific climatic conditions to thrive and persist. And back in Eastern North America, a lot of those environments tend to be caves and mines, and that's also where they find a lot of their bats hibernating. And it is an invasive species. It likely originated from Eurasia. There's been a lot of work done over in Eurasia to figure out the distribution of PD or white nose, and they did find that there is a high diversity, which suggests it's been there for a long time. And also they have been noticing white nose syndrome in the bat populations, but they are not seeing mortality, the rate of mortality that we are seeing here in North America. So then again, that suggests coevolution with this pathogen. So here is the spread map. You can kind of see there's a little red circle around this purple county here in New York. That was the first detection of the disease. And you can see since then it has spread across Eastern North America and into the Midwest. The red counties are the most recent detections. So as of last year, this map will be probably updated in the next month. Since all the diagnostic labs are running tests currently from this current winter spring work. And as you can see, we do have 2 counties here in Washington where the disease has been found. And I'll talk a little bit more on that in a little while. This disease has killed millions of hibernating bats in Eastern North America. It's been really devastating for some species. The mortality rate can be over 90% at some hibernacula. And I underlined hibernating here because that's when the disease impacts bats. It's when the bat's immune system is suppressed, and that allows the fungus to invade the epidermis of the hairless areas of the bat and infect them. And it's primarily transmitted by bat-to-bat contact, like you see in this photo. Some species tend to hibernate in close proximity to one another, but it also can be spread from bat to environment or environment to bat. And as I noted, that this is a cold-loving fungus, so it can persist in these cooler environments without the host there. So that's why the environment is also a way for it to be transmitted. But it has been demonstrated that humans can spread it as well, either on footwear or clothing or equipment that have gone into infected areas. And just wanted to note that this does not infect humans or other wildlife. It only infects bats. And so what it does is it causes bats to rouse from hibernation early, which causes them to burn that critical fat reserves they need to survive through months that have no food or water, particularly in the eastern North America where there's snow from November to March or April. But it also has physiological implications. You can see in this upper photo, there's pretty severe wing damage there, and that can cause it affects their ability to thermoregulate or for water exchange. And then it also can affect their ability to fly if they do survive through the winter into the spring. And so then they won't be able to forage successfully. So some of the clinical signs that we look for, again, what the disease is named for, this white fungus on the nose or the other hairless areas of a bat. That is only can be observed when the bat is hibernating. Once they become active and start flying, you no longer will see these growths anymore because it's a very delicate fungus. It's like what you see growing on bread sometimes. So it's very similar to that. We're looking for excessive bat mortality at colonies either in the spring or in the winter. Some abnormal behavior, so activity in freezing temperatures or during the daytime or just found on the ground. That doesn't always mean white nose syndrome. There are a lot of other things that can factor into that behavior. And for some species, that actually is normal behavior. So it can be a little complicated. So we mostly rely on some of these other clinical signs. Dehydrated and thin body condition, like I said, it causes them to rouse prematurely or frequently through hibernation, and they're depleting those fat reserves. And then wing damage is, again, another clinical sign that you see in this photo. And then also our most reliable way to screen for white nose is looking for yellow-orange fluorescence using a UV light in their wings. And you'll see in this lower photo, if it had white nose syndrome, it will fluoresce orange, and that's from the fungus. When it invades the epidermis layer, it causes the bat's immune response to slowly start to respond to it, and it causes it to sequester iron. And so you'll still see that iron, even if it doesn't have white nose syndrome anymore. So that's something we can still see for a few weeks after they may have cleared the infection. So that's really been a reliable technique for us here in Washington. So there are currently 11 species confirmed with white nose syndrome. And like I said, some of the impacts on some of these species have been pretty detrimental, particularly with this northern long-eared bat. This species now is federally threatened, but there are other species here that are now listed for other states as threatened or endangered. And here in Washington, we have 4 of these species: the little brown, the Yuma, the big brown, and the long-legged Myotis. But we also have 10 other species, and these other species have not, this is a new disease for them, so we do not know how they will be impacted. And there's also species that can carry the fungus but not show symptoms of the disease, so they are potential vectors here. So 4 of these are found in the Western United States, but these bottom 3 here are found in Washington. And like I said, again, we really just don't know which species are going to be susceptible to white nose or which ones can potentially move this fungus across the landscape. So there's a lot of unknowns that we're still trying to understand now that we discovered here in Washington. And just to give you an idea or example of some of the population declines, this is this data back from 2000, or compiled in 2014. From winter surveys at Hibernacular Northeast. And you can just see the varying mortality rates by species here. But you can see some of these mortality rates are really high, 96% at this northern long-eared bat. But they can be pretty low for some species like the big brown. And what's interesting now that the disease has been back east for over a decade now, they are starting to see some species having a remnant population starting to reproduce and survive each year. So that's encouraging to hear. But these varying trends and species response to the disease have also been observed throughout the Midwest. So it does seem to be some species-specific responses to this. As far as management, so the U.S. Fish and Wildlife Service, they are the lead agency in guiding our response to the disease in the U.S. They developed a national plan, again, which is to guide our federal, state, and tribal agencies and partners' response to white nose syndrome. But they work really closely with each state or other agencies to integrate their work or their plan with each state's plan. And I'll just note it here that Canada also has a national plan, and they work really closely with the U.S. and vice versa to manage and respond to this disease. And so the U.S. Fish and Wildlife Service, they do provide new initiatives and funding programs to support research and management. And that's where the Washington Department of Fish and Wildlife, we get a lot of our support is through these grants with them. And a lot of the work or a lot of the actions currently have been focusing on containment and conservation. But there now has been some work looking at treatments. There's been some very promising ones in lab settings, and now they're trying to figure out how to apply that to the environment. And so here's just some examples of some of those treatments that are being investigated. As you already, the previous presenter talked about this disease triangle. So these treatments are either targeting one side of this triangle. And so you have microbial or biological derived antifungals, either applied to the environment or to the bat. Some researchers are looking at vaccines to help the immune response of bats as they go into hibernation. Some are looking at habitat manipulation or cleaning environments, or providing a roost in the spring or winter to help the bats that do emerge early to survive through the cold winter. So they're looking at like heated bat boxes, for example, and how that might help the bats survive until there's food or water. Gene silencing or therapy, and then UV light. As I mentioned, we use that to screen bats for clinical signs. But another wave, I think it's UVC, don't quote me on that, but there's a publication on this that has shown to kill PD in the lab. So they're now testing that in the field setting this year. So we'll see what those results are. And then some additional conservation management measures that the U.S. Fish and Wildlife Service have been implementing. They have a cave advisory document. They have guidelines for wildlife control operators, for wildlife rehabbers, also for transportation infrastructure and forest management practices. They also have been developing a North American Bat Conservation Alliance, so Canada, US, and Mexico, to talk about bat conservation issues and white nose syndrome. And then they also have led the development of a decontamination protocol. And so this decontamination protocol is really just to reduce that risk of long distance spread by humans. And so this protocol, it provides guidance on procedures for doing that. So there's a whole list of products that show efficacy against PD. So for example, like bleach or isopropyl alcohol, for example. They also provide guidance on trip planning, organization, and your gear equipment recommendations. And so that could be having gear dedication. So any equipment ever used in an infected area should never leave that area. And so these protocols can be found on this website, whitenosesyndrome.org, as well as all those other guidance and documents I just mentioned can be found on that website. And I just wanted to mention that Department of Fish and Wildlife, we've been working with a national group to develop a step-by-step guideline for decontamination. If you get a chance to read the national protocol, it's very broad and it's meant to be, which can be tricky to implement for someone that's new to this field. So we wanted to make a step-by-step guide to facilitate cooperation and participation in this. Because currently this is our best way of limiting the spread of the disease Because currently we're not quite sure how treatments can be applied in Washington. And so now I just want to shift gears and focus more on Washington. Again, you can see there are 2 counties here that we've detected the disease or the pathogen. So this is a close-up view of around Seattle. So let's see, here is Seattle. And so this is King County, and you can see most of our detections have occurred in King County. The first one occurred in 2016, and that was in a little brown bat. This bat was actually found alive by a hiker. The bat just happened to be on the ground on a trail. And they took the bat to a wildlife rehabber in Seattle named Paws, and luckily their veterinarian was aware of the clinical signs and knew to look for that. And if he didn't, I don't think we would know that white nose is here. But so after that detection, there was a lot of collaboration with state partners and stakeholders and the public to start looking for this disease. And so we worked with the Department of Health. Any bats that came into their facility, we wanted to make sure they were getting swabbed or assessed for clinical signs. And so just a few weeks later, after this first detection, a silver-haired bat found, again, just outside Seattle here, was positive for the fungus. So it didn't have the disease, but it was carrying the fungus. And then since then, we have a total of 36 cases of either the disease or just the fungus. Last year, we did detect it in Lewis County, and this is just the fungus. So currently, we don't have confirmation that the disease is there, but it's suspect. And we're doing more investigation there just to confirm this county has white nose. I also just add that we now know that the Yuma myotis is susceptible to white nose here in Washington. And you can see this bat, you can see that, or maybe you can see it, but there's orange fluorescing of the wings. And that bat was found dead. And so it could have been out for a few weeks, but we were still able to see that clinical finding. And so after that initial detection, one of the main questions was, what are these potential impacts going to be on Washington bat populations? Is it going to be similar to Eastern North America? And there's a lot of unknowns about the roosting ecology for Washington bat species that makes it difficult to know how to answer that. For example, we're unsure which species use hibernation to survive through the winter, and thus they'll be susceptible to white nose. There is some evidence that there's some species that are active year-round, in which potentially they might not be as vulnerable. We also, for those species that do hibernate, we're not quite sure where they're going to hibernate. So we don't know how to look at those environments for environmental reservoirs or what the suitability of those roosts are for PD to persist and thrive. And so another strategy for surveillance is to look at maternity roosts, since we do know where some are. But when we look at our database, at least our state database, we don't have a lot of information on summer roosts for many species as well. So again, it makes it very difficult to do surveillance and population monitoring and to try to understand what these impacts is going to be. And so DFW developed a response plan, again, using the national guidance as a way to develop it. We have 4 key objectives in this plan, and this plan can be found on that website, again, whitenosesyndrome.org. One is to develop outreach products and education programs to talk about bat conservation and white nose syndrome. We also want to investigate and understand the distribution and ecology of white nose, and then understand the natural history of Washington bat species and monitor those populations. And then lastly, to safeguard bats from sources of white nose mortality. And currently, that's our main activity has been decontamination for that last objective. So now I'll just go quickly through some of the activities we've been conducting and implementing the past 3 years, I guess now, to start meeting these objectives. So first, outreach. We developed lots of outreach products, so stickers, rat cards, posters, which I brought some of those so you can find them on the table there. We've been attending outreach events. We have bat skins and just try to reach people about bats and why they're not scary. They're really cool. You shouldn't be scared of them. We partner with groups called Bats Northwest and other nonprofits to help spread the message about bats and white nose syndrome. We also launched social media advertisements and just posts to try to reach people. And we had a pretty successful campaign this past fall where we reached, I think, 180,000 accounts, which is great for the cost of doing that. And then we also created a bat educational trunk so teachers can rent them out, or if you're going to a workshop, you can rent these trunks out and they have activities, and then for students or other professionals. And then we did develop a reporting tool on our website here. And we are encouraging the public to submit bat observations to us, either groups of bats or sick bats, which again help us find new colonies and to also test these bats for white nose syndrome. And just to give you an idea of how successful we've been with this public reporting tool, since 2016, we've had over 164 reports from the public on groups of bats, and we've been able to verify 59 of those so far. So we're going out and making sure the colony actually is a colony, what species are there, and what the colony size is. And so this is just map showing you that we're getting a lot of reports in Western Washington, but we're still lacking here in Eastern Washington. And then again, we're doing surveillance. So we go to maternity colonies in the springtime, since we don't know where hibernaculum are, but we can still detect the fungus if we target it in the springtime, and we still see those clinical signs. So we're swabbing bats, and in some cases, we might just be collecting environmental samples like guano or swabs from the roosts. That's another way we can detect the fungus. We also been working closely with the Forest Service. They have several showcases in the state, and they want to make sure we're monitoring those sites so we take a look at that human spread side of things at those sites. And then, like I said, we work closely with wildlife rehabbers, Department of Health, even wind energy facilities to screen bats and sample bats that they get to their facilities for white nose. And then this is just a map showing the areas that we've been sampling, actively going out to roost and collecting samples from 2017 and 2018. And so we've been able to sample 75 roosts so far. And then we are going to be starting our work in the next week. And then monitoring, like I mentioned, we are following up on colony reports, just verifying that there are actually bats there. These are actually photos from some of those reports, and you can see some of these are pretty substantial size colonies. We are doing colony counts, trying to get population trends. And then we're doing acoustic monitoring as well, just to try to look at activity levels and try to piece together the natural history of these bats in Washington. And then again, we're doing telemetry to again try to understand where these bats are going to roost and learn more about their natural history. And so with that, I don't think I have time for questions, but here's my contact information and Anne's as well. So feel free to reach out to me or her if you have questions. And then real quick, this is a huge partnership with so many different entities, and we're able to do what we do through these partnerships. So we're really grateful for that. So thank you.